For problem number 3, it looks a little intimidating, but don't worry about it. It's just 3 systems of equations written as one, where we have the same a vector. So this and this would be the first equation, this and this would be the second system of equations, and this would be the third system of equations. But we've written it as one. It still operates the same, so don't be intimidated by the way it looks. A, determine the inverse of matrix A. You're not told which method to use, so you have 2 options: Gauss-Jordan elimination or cofactors. I find cofactors personally a little bit easier to debug, a little bit easier to work with. There's more independent things, whereas Gauss-Jordan elimination builds on itself. So I'm going to go ahead and use my cofactors. So my grid is plus, minus, plus, minus, plus, minus, plus, minus, plus. So I go ahead and find C11. I get plus, and then take out that row, take out that column. So I get 1, 1, 0, negative 2. So it's going to be negative 2 minus 0, or negative 2. 1, 2 is going to be minus, and then 1, 0. Come on. 1, 0, 0, negative 2, or minus negative 2 minus 0, or positive 2. And then C1, 2, I'm going to go ahead and stop writing this because it's extra work. 1, 0, 1, 1, or plus 1 minus 0, 1. And then for my next column, or my next row, I get minus, take out the row, take out the column, leaving me with 2, 1, 1, negative 2, or negative 4, minus 1, or 5. And then I get a plus, 2, 0, 1, negative 2. So that one becomes my corners. So I get a negative 4 minus 0, or negative 4. And then I keep going, minus 2, 0, 2, 1. Or negative 2 minus 0, or negative 2, positive, negative 2 minus 0, there we go, negative 2. And then my last one, positive 2, 1, 1, 0. The more you do this, the more you'll just recognize where your cofactors come from. So I get 0 minus 1, or negative 1. And then minus 2, 1, 1, 0, or negative 0 minus 1, or positive 1. And then mine plus 2, 1, 2, 1. I automatically know that determinant is going to be 0 because those 2 columns are the same. And as if you have 2 columns that are the same, your determinant, or multiples of each other, your determinant equals 0. Okay, so there we go. I have my adjoint matrix. I'm going to take these numbers and transpose them. So negative 2, 2, 1. 5, negative 4, negative 2, and then negative 1. Come on, pen. Negative 1, 1, and 0. I need to go ahead and find my determinant still, but I already have my cofactors, so I can go ahead and easily find that. I'll use column 1 for kicks and giggles. So plus 2 times negative 2, its corresponding cofactor. Minus 1 times 5, its cofactor, plus 0. So that means negative 4, minus 5, although that should not be plus 2. I did something wrong. My determinant should be 0. If at any point in time you're getting something that doesn't match, if you're getting fractions on your exam, double check your work. So I'm going through, I already included the cofactor, so it's just 2 times negative 2, 1 times 5, there we go, that should be a plus. My determinant is equal to 1. If you already have the sign included in your cofactor, you do not need to alternate your sign when you do your determinant. Okay, so keep that in mind. So my determinant is equal to 1, therefore this here is A inverse, because all I would do is just divide everything by 1. So there's A inverse. Verify that A inverse is the inverse of A. Okay, so verification means I literally take A and I multiply it by A inverse. It doesn't matter the order for doing this matrix multiplication, because A inverse times A equals I, A inverse, or an A times A inverse equals I. But I need to still show this. Let me zoom back in. So I'm gonna have, if I take row 1, column 1, I get -4 plus 4 plus 1. Row 2, column 1, -2 plus 2 plus 0. 0 plus 2 plus 0 plus 2 plus, did I miss a sign? That's a -2. There we go. -2. If you do miss something, go with the numbers you have. If you need to explain it later, like if you forgot this minus and it messes up, obviously it would mess up your calculations, right on the side say, I know it should be I made a short mistake. Okay, that's all you need to do. Okay, if your answers don't match what you expect, then just tell us that you know that. Otherwise, we're just like, okay, they're just trying to, I don't know, work their way through something, and they're trying, essentially, if you just make things up, then it doesn't tell us you know what you're doing. It tells us that you can just make things up. -2 plus 2 plus 0, -1 plus 1 plus 0, and then 0 plus 1 minus 2, nope, plus 0. And if you do that, you do get identity. Verified. Okay, last thing. Use the inverse of A inverse to determine X. If we have AX equals B, my solution X equals A inverse times B. This order matters. It needs to be A inverse times B. Even though you have a 3 by 3 here for B, it still applies. So you just do that multiplication. So let me go ahead and zoom out so I can see what my B matrix looks like, because I already know what A inverse looks like. 0, 1, -2, 2, 2, -1, 0, -3, 0, 1. And then A inverse, which this one is way inverse. Okay, we just do the matrix multiplication, same way we did it before. Except now we don't know exactly what our numbers are going to be. So 0 plus 5 plus 2, 0 minus 4 minus 2, 0 minus 2 plus 0. Next one, -4 minus 5 plus 0. Uh, 4 plus 4 plus 0. And then 2 plus 2 plus 0. And lastly, we have 6 plus 0 minus 1. So minus 1. And then -6 plus 0 plus 1. And then -3 plus 0 plus 0. When I do that, I end up with X equal to 7, -6, -2. That's my first column of X. -9, 8, 4 is my second column. And 5, -5, and -3. And there we go. If you ever want to check your answers, you can just take a X equals your B. So now, rather than doing X inverse or A inverse times B, you can just double check it and write your A matrix times what you got for X, and check to see if that's equal to B. If you have time. It's a little bit more tedious if you have a bigger system like this where you have X is a 3 by 3. Notice it still operates the same. This still applies. It just so happens X is a little bit bigger, B is a little bit bigger. But if you have time, go ahead and do that verification just to check and make sure that you got your answers correct.